For any help regarding mathematical statistics homework help, visit https://www.statisticshomeworkhelper.com, email info@statisticshomeworkhelper.com, or call us at +1 678 648 4277. For any help regarding mathematical statistics homework help, visit https://www.statisticshomeworkhelper.com, email info@statisticshomeworkhelper.com, or call us at +1 678 648 4277. Mathematical statistics homework help. Problem 1. Give an inductive proof that the Fibonacci numbers fn and fn plus 1 are relatively prime for all n greater than or equal to 0. The Fibonacci numbers are defined as follows. f0 equals 0, f1 equals 1, fn equals fn minus 1 plus fn minus 2 for n greater than or equal to 2. Solution. We use induction on n. Let Pn be the proposition that fn and fn plus 1 are relatively prime. Base case P0 is true because f0 equals 0 and f1 equals 1 are relatively prime. Inductive step. Assume that Pn is true where n greater than or equal to 0, that is, fn and fn plus 1 are relatively prime. We must show that fn plus 1 and fn plus 2 are relatively prime as well. If fn plus 1 and fn plus 2 had a common divisor d greater than 1, then d would also divide the linear combination fn plus 2 minus fn plus 1 equals fn, contradicting the assumption that fn and fn plus 1 are relatively prime. So fn plus 1 and fn plus 2 are relatively prime. The theorem follows by induction. Problem 2. The double of a graph G consists of two copies of G with edges joining corresponding vertices. For example, a graph appears below on the left and its double appears on the right. Statisticashomeworkhelper.com. Some edges in the graph on the right are dashed to clarify its structure. A. Draw the double of the graph shown below. Solution. B. Suppose that G1 is a bipartite graph, G2 is the double of G1, G3 is the double of G2, and so forth. Use induction on n to prove that Gn is bipartite for all n greater than or equal to 1. Solution. We use induction. Let Pn be the proposition that Gn is bipartite. Base case P1 is true because G1 is bipartite by assumption. Inductive step. For n greater than or equal to 1, we assume Pn in order to prove Pn plus 1. The graph Gn plus 1 consists of two subgraphs isomorphic to Gn, with edges joining corresponding vertices. Remove these extra edges. By the assumption Pn, we can color each vertex of one subgraph black or white so that adjacent vertices get different colors. Statisticashomeworkhelper.com. If we color the corresponding vertices in the other subgraph oppositely, then adjacent vertices get different colors within that subgraph as well. And now if we add back the extra edges, each of these joins a white vertex and a black vertex. Therefore, Gn plus 1 is bipartite. The theorem follows from the principle of induction. Problem 3. Phinophobia is a rare disease in which the victim has the delusion that he or she is being subjected to an intense mathematical examination. A person selected uniformly at random has phinophobia with probability 1 out of 100. A person with phinophobia has shaky hands with probability 9/10. A person without phinophobia has shaky hands with probability 1 to 20. What is the probability that a person selected uniformly at random has phinophobia, given that he or she has shaky hands? Solution. Let F be the event that the randomly selected person has phinophobia, and let S be the event that he or she has shaky hands. A tree diagram is worked out below. Statisticashomeworkhelper.com. No 99 out of 100 yes 1/100. Has shaky hands? Yes, September 10th, January 10th. No, 1/20th, 19/20ths. No. Has final phobia? FSXX9/1000. 1801/2099/2001/1000. Probability. XX. The probability that a person has final phobia, given that he or she has shaky hands, is PR, F intersection S, PR, S, 9/1000 PR, F, S, equals 9/1000 plus 99/2018 equals 18 plus 99. 117. Equals. Statisticashomeworkhelper.com. Problem 4. Suppose that you roll 5 six-sided dice that are fair and mutually independent. 4. The problems below, answers alone are sufficient, but we can award par-tile credit only if you show your work. Also, you do not need to simplify your answers, you may leave factorials, binomial coefficients, and arithmetic expressions unevaluated. A. What is the probability that all 5 dice show different values? Example. 1, 2, 3, 4, 5 is a roll of this type, but 1, 1, 2, 3, 4 is not. Solution. The probability space is the uniform distribution on the 65 possible number bears rolled on the 5 distinguishable dice. So the probability that all dice are different is the number of outcomes in which the dice have distinct values divided by 65. There are 6, 5 equals 6, 5, 4, 3, 2 such outcomes, so PR, all rolls distinct, equals 6, 5, 4, 3, 2 equals 5. 6, 5, 6, 4. An alternative approach uses the observation that the conditional probability that the I plus first die value differs from the preceding rolls, given that the first I values differ, is 6 minus I/6. For 1 less than or equal to I less than or equal to 4, and the probability that all 5 values are different is the product of these conditional probabilities, namely 6, 6. PR, all rolls distinct, equals 5, 4, 3, 2, 5. 6, 6, 6, 6, 64. B. What is the probability that 2 dice show the same value, and the remaining 3 dice all show different values? Example. 6, 1, 6, 2, 3 is a roll of this type, but 1, 1, 2, 2, 3, and 4, 4, 4, 5, 6 are not. Statisticashomeworkhelper.com. Solution. There are 5 possible pairs of rolls that might have the same value, and 6 possibilities for what this value is. There are 5 for 3 possible distinct values for the remaining 3 rolls. So, PR, exactly 2 values the same, equals. An alternative way to count is, there are 4 sets of 4 values among the 5 dice, for choices for which of these values is repeated, and by the bookkeeper rule, 5 equals 5/2 permutations of a sequence consisting of 5 values, one of which 2, 1, 1, 1 appears twice. So, PR, exactly 2 values the same, equals. C. What is the probability that 2 dice show one value, 2 different dice show a second value, and the remaining die shows a third value? Example. 6, 1, 2, 1, 2 is a roll of this type, but 4, 4, 4, 4, 5, and 5, 5, 5, 6, 6 are not. 2, 6 solution. There are sets of 2 values that might be duplicated. There are rolls where larger duplicated value may come up and 3 halves, remaining rolls where the smaller duplicated value may come up. There is only one remaining roll where the non-duplicated value may then come up, and 4 remaining values it could take. So, Statisticashomeworkhelper.com. PR, exactly 2 pairs of same values, equals. Alternatively, there are sets of 3 values among the 5 dice, 3 choices for